Okay, now we're entering into washer method. So when you're doing washer method, you're pretty much doing disk method twice and subtracting them. Okay, so the way this looks like is like this. Okay, so we're revolving around the x-axis. Okay, and from here to here, that's going to be the radius of the inside part. This is kind of like a void right here. That's the hollowed out part of the solid. And then you have the other part, which would go from here to here, and that's going to be the solid part. Okay, so it's going to be the upper solid minus the inner solid. Okay, I think that other circle kind of like makes it look confusing. Okay, so this is our inside radius. Let's do our outside radius first, because that's the bigger area. Now we're going to go from 0 to wherever these intersect. I don't see... Oh, wait, it does. It gives us a 1. So that's where they intersect. And we're going to say pi r squared, because that's our formula for the circle, pi r squared. But we need the r to be an x. In this case, to go from here to here, that radius right there is defined by x. And so we just need to put an x in there. So it's going to be pi x squared. So I'm going to put a pi x squared inside, dx. And then I'm going to subtract the inner circle. The inner circle has a different radius. That one is defined by the x squared. So we're going to go say minus from 0 to 1 pi r squared dx. And what is my r this time? This time it's x squared. There is a way to combine these, but you don't have to do this, okay? I could take out pi as the scalar, 0 to 1, because both of the lower and upper bounds are the same. And then I subtract the two radiuses squared. So it would be x squared minus x squared squared dx. And if you would rather just do one integral, you can simplify this down to 1 and then do it, which I think I'm going to do. So I have pi from 0 to 1, x squared minus x to the 4th dx. Then I have 1 over 3 x to the 3rd minus 1 over 5 x to the 5th. And I need to plug in 0 and 1 and then multiply it times pi. Next, plug in 1 first. I get 1/3 minus 1/5 minus, now I plug in 0, I get 0 and 0, so I'm just going to write 0 like that. And then don't forget your pi, got to multiply it by pi. I have 1/3 minus 1/5, but just like the other one that we just found out, we can just leave it like this and plug it in to Khan, and he'll give it to us. We don't have to find common denominators and simplify it. If you do, you're not going to be wrong. It's just you have a chance of making a mistake. So I'm just going to leave it like that.